Hello friends, today we'll see the seventh chapter, that is performing conditional processing. Now in this chapter we'll see the tools that will allow programs to make decision based on data values. For example, you may want to read a value of age and create a variable that represents age group. You may want to determine if values for a particular variable within predefined limits. Programs that perform any of these operations require conditional processing, which is the ability to make logical decisions based on data values. So we'll see first the if and the if-else statements. Two of the basic tools for conditional processing are the if and else if statement. To understand how this statement work, suppose you have collected data on a large group of students based on the following variables: age in years, gender, which is recorded as male or female, then the midterm grades, which is the grades on the midterm exam, then quiz, which is basically the quiz grade from F to A plus, how they are been given, then the final exam, the grade on the final exam. Now your first task is to create a new variable that represents the age group. Here is how you normally do. Okay, first you write a data conditional length, gender, dollar, quiz, dollar, now we'll input age, gender, midterm, quiz, final exam, now we'll write the if statements. If age less than 20, then age group equal to 1. If age greater than 20, then and age less than 40, then age group equal to 2. So similarly we'll do it for yep. I'll change here this to 40 60, make it age group 3, and lastly if age greater than 60, then each group equal to 4, and we'll keep the data lines. Suppose 21 is 80 B minus and 82. Suppose here the data is missing, we'll keep F. A 93 49 F 'So all these dots are the data missing. 76. I'm including in this example so that it gives a better perspective in what we are doing. And 59, suppose F. We have suppose 95 E plus 97 15 M 88 dot 93 67 F 97 E 91. Then keep this as missing and we'll keep 62 F 67. Just arrange this. C 81. Okay, so these are the data lines, and we'll write the display, that's title, listing of give the proc print data equal to conditional and no OBS, that's no observations, and we'll finish with the run statement. So we'll run the first data step along with the data lines. So the conditional data set is created. And it has taken up all the fields that we have supplied. Okay. Now we'll run the proc print step for the listing. Now see, this is the listed. So this is a very normal procedure how you are going, how you usually do for grouping of data according to certain conditions. So okay, one more thing I think I should mention about is the mnemonics. Now the logical comparisons and what are the equivalent mnemonics. So mnemonics are like what I have used here, LT, GE. Now when it is equal to, we use the mnemonics as EQ. When it is not equal to, we use it NE. When it is less than, we use LT. When it is less than or equal to, we use LE. When it is greater than, we use GT. When it is greater than or equal to, we use GE, like what I have used here. When it is equal to 1 in the list, we say IN, that's in. So let's follow the logic of this program what we have mentioned. Now the first if statement asks if the age is less than 20. When the logical expression following the keyword if is true, the statement following the word then is executed. Now if the expression is not true, the program continues to process the statement in the data step. However, there is one serious problem with this program's logic, and it relates to how SAS treats the missing numerical values. Now, missing numerical values are treated logically as the most negative number you can reference on your computer. Therefore, the first if statement will be true for missing values as well, as for all the ages than 20, which is less than 20 here. Now, this is a very important point. It is a good example of a program that has no syntax error, runs without any warning or an error message in the logs, and produce incorrect results. There are several ways you prevent the missing values from being included in the age group 1. It can be like this, that if we'll write it like if age less than 20 and NE not equal to dot, that is missing, then age group equal to 1. So this is one way. Another way is if we'll mention like if age greater than equal to 0 and age less than 20, then age group equal to 1. So this is one of the several ways we can use. Also, like if 0 less than equal to age less than 20, then age group equal to 1, or if age less than 20 and not missing, age, then age group equal to 1. Okay, so all of these statement results in the correct value for the age group. Now subjects with a missing value for the age group will also have a missing value for the subjects which are having a missing value for the age will be also having a missing value for the age group. Now the first if statement uses the fact that you refer to a numeric missing value in a data step by a period. Okay, here now if now the last if statement uses the missing function here, not missing, so that's the missing function, and false if, and the false if the argument is not missing. Okay, so when the function returns a value of when we operate the when we execute the last statement, the if age lt 20 and not missing, so when we execute the statement, this function returns the not missing function. It returns a value of true if the argument is missing, and false if it's not missing. Now this program can the program what we have written here, the first program, this can be further improved. If a person is less than 20 of age, the first if statement is true and the age group is set to 1, all the remaining if statement are still executed. So a better way to write this program is to change all the if statement after the first one to the else if statement. So we'll write how does this program can be written in the correct format. Okay, I'll just copy this part and okay, let me go ahead and copy this also. It's easy for me then. here we'll change it as if age is less than equal to 20 and not missing age. Then age group 1. After that we'll write else if age greater than 20 and age less than 40, then age group equal to 2, just copy the statement here. I'll change this to 40 and less than 60. Here this is 3. Here just copy the statement and make it greater than 60. Then age group equal to 4, right? And we'll give the data lines. Just copy this data lines. So this is the output from this is the same, but the logic of the program is far better than first what we have wrote. So we'll just execute this and run this. So you see it's the same result, but the logic how the program is executed is a lot better. Okay, let's look at an alternative way to write the program, this program. Okay, I'll just copy it, this statement, and yep, this. And we'll write if missing age then age group equal to 1, else if age less than 20, then age group equal to 1. I need to copy it. There you go. I think I have 3 lists and okay, so easy for me to modify here. So make it 40 and make it 60. Let's make this G greater 60. So this would be second, third, and the fourth. So if age less than 40, the age group is 2. If age less than 60, the age group is 3. If age is greater than 60, the age group is 4. And the data lines. So when we'll run this program, it will give us the same output. Okay, and you see it, in all of this you have the same output, but every time you are using a different logic for comparing and using the conditionals. And in this program, the first if statement is false. For example, what if a person's age is 25 years old? Then the first if statement is false because age is not missing. Then next else if statement is evaluated and found to be false as well. Finally, the third statement is evaluated and the age group is set equal to 2. So this is how the logic works here. Now if you are working with very large data set and want to squeeze every last drop out of the efficiency tank, you should first place the if statement in order. That is how. Otherwise it's you can follow any normal standards of coding. Now we'll look at subsetting the if statement. Now if you want to take a subset of data from a raw data file or from an existing SAS data set, you can use a special form of if called as subsetting if. As an example, let's use the same raw data from the program, the first program, but let's restrict the resulting data set to the females only. Okay, so we'll write the program. I'll just copy this because this is the main. Then we'll use if gender equals to female, and we'll keep the data lines. Let's run the program. Okay, let's write another program to display it also, otherwise we'll not know. Title title listing of females proc print data equal to female, no OBS, change the dataset name. Let's name it as females. Okay, and we'll run it. So it's telling that 5 observation, the dataset is created. So you see the genders, there are only females, and there are 5 observations which have been recorded. We'll display those results. So you see the 5 datasets and the gender which has been only selected, that's females. So notice in this program what I have written here, there is no then following the if program. If the conditions is true, if the condition is true, then the program continues to the next step, next statement. Now if the condition is false, the controls return to the top of the data step. In this case, the only statement following the subsetting if statement is a data line statement. Now if the value of the gender is F, then the end of the data step is reached and an automatic output occurs. Now if the value of the gender is not equal to F, the control returns to the top of the data step, and the automatic output does not occur. Okay. Next we'll look at the in operator. Now if you want to test a value, suppose if you want to test if a value is one of the several possible choices, or use a multiple or statement, we can use a multiple or statement. Like, let's show you. Like if if quiz equal to A plus, or quiz equal to A or quiz equal to B plus, or quiz equal to B then quiz range equal to 1, else if I'll just copy this. I guess I'll copy this also, little easier for me, and I'll modify this. Suppose we'll make it B minus and C plus and C take out this or, then the quiz range is 2, else if not missing quiz, then quiz range equal to 3. Okay, so this is how you use a multiple OR statement. You can use it like this, but you can still use a very simplified form, and by using a in operator. And how do you use that? Is like if quiz in A plus A B plus B then quiz range equal to 1. Else if quiz and the rest of the ranges, that is B minus C plus and C, then quiz range equal to 2. Else if not missing quiz then quiz range equal to 3. Okay, so the list of values in the parenthesis, as you see in following the in, it can be either separated by blank or commas. Okay, so you have all the values listed, which is like a kind of a range kind of a thing, and you want all the values which are coming within this range should come into the quiz range 1. So this is how you use a in. You can also use the in operator with numeric variables. For example, if you had a numeric variable called as subject, which is stored as a numerical value, and you wanted to list observations for subject numbers as 10, like 22, 25, 33, then you use the where statement like this, where subject in 10, 22, 25, 30. Okay, as with the examples using the character values, you may separate the values with spaces or commas. Okay, you can also specify a range of numeric values using a colon to separate values in the list. So for example, where the subject is like 10, 20, here I can give 10, 22 to 25 and 30. I can use it like this. We can use it like this also with a semicolon. Okay, so now let's see how do we use a select statement for logical test. Now a select statement provides an alternative to a series of if and else if statements. I'll show you with an example. We'll say like select age group and when 1 limit equal to 110. So same thing, we can do it. Just copy paste it. Okay, when 2, when 3, let's make it 20, 30. So the expression following the select statement is referred as to the select is referred to as the select expression. The expression following the when statement is referred as to the when expression. In this example, the select expression age group is compared to the each of the when expression which is executed, and the control skips to the end of the select group. Okay. Oh, I didn't mention the otherwise to end it, and we'll write the end statement. Right. So now if the comparison is false, the next when expression is compared to the select expression. Now if none of the comparison is executed to be true, evaluated to be true, the expression following the otherwise statement is executed. Now as you can see in this example, the otherwise expression can be a null statement also. It is a good idea to include an otherwise statement because the program will terminate you if you omit it, and none of the preceding comparison is true. So you can place one or more values in a when expression like 3, 5. So when you will do that, the age value groups are either 3 or 5. So now if you do not want to supply a select expression, each when statement is evaluated to determine if when expression is true or false. Okay, I'll show you with an example wherein we will demonstrate a select statement when a select expression is missing. Data conditional, we'll use the same data set, just copy here. here we'll write select when missing age will keep age group equal to dot when missing sorry, not missing, but when age less than 20 age group equal to 1. Just copy it. So first is less than 20, then next is less than 40, the age group will be 2, then it would be 60, the age group will be 3, and this is, will make it greater than 60 and make it 4. You'll end it with otherwise and we'll keep the data lines. Okay. Now notice there is no select expression in this select statement. Now the when expression is evaluated, so each when expression is evaluated, and if true, the statement following the expression is executed. Okay, I'll execute it. Yup. Okay, let's go into the Explorer. Let's see the conditional. So is the same output. Now let's see how we will be using the Boolean logic, the AND, OR and the NOT operators. You can combine various logical operators, also known as the Boolean operators, to form fairly complex statements. As an example, I do have a data set which is medical, and it contains information on clinics, diagnosis and weight. Then we'll make a program to list all the patients who were seen at the clinic, okay, and they had either a diagnosis 7 or 9 or weighted over 180 pounds, suppose. Okay, so I'll show you how the data set is, the clinics on which we'll be running our program. Okay, here we have clinic number, the clinic name, the region, last name, first name of the patient, social security number, you have the gender, you have the date of birth, date of death, race, education in years. Then you have height, you have examination date, symptom code, date of diagnosis, diagnostic code, and admit date, procedure code, discharge date. Okay, so let's make a maybe for convenience sake we'll take another dataset, which is the learn.medical. It's smaller dataset, okay, with less variables so that it's easy for us. Okay, we have the same like patient number, the clinic name, the visit date, weight, heart rate, okay, and the comment, the diagnostic type also. Okay, I'll go ahead and write the program. Title, example of Boolean expression, okay, and proc print data equal to learn.medical where clinic is equal to, suppose, a clinic name HMC, and the diagnostic type, that's DX in seven or 9 or weight greater than 180 and we'll have ID as patient number, we'll have the variables listed, that's variables are the patient number and clinic, the diagnostic number, weight, and visit date, and we'll run the program. So you see here the output, we have the patient number, but we have the clinic, we have the DX, we have the height, and we have the visit date. Right? So notice the parenthesis around the two statement separated by or. Here there are the two statements and it is separated by or. So it's the same way of precedence where we look that if x and y or z, so it's the same as parenthesis x and y and or z. So if you want to perform OR operation before the AND operation, you use the parenthesis, okay, wherein you make it like suppose if x and y and z, okay. So use it like this, okay. So in the last program which we saw, we wanted that the clinic to be an HMC, and we wanted that either the diagnostic to be one of the two values, or the weight of has to be over 180 pounds. So you needed the parenthesis to be first decided either the diagnostics or the weight condition is true before performing the AND operations with the clinic variable. Even in cases where parentheses are not needed, it is fine to include them so that the logical statements are easier to be read and understood. Now let's check out the where statement. Now if you are reading the data from a SAS data set, you can use a where statement to subset your data. For example, if you have started with the SAS data set conditionals, then you could write the data set like in the program which I showed you in wherein we listed the females, okay. This is the data wherein we listed the females, okay. So we'll rewrite the program and we'll be using a where statement to subset this data set. So we'll write data females and we'll set conditionals set conditional where gender equals to female, and it will run the program. Let's go to the Explorer bar, the work. See, the same result is created. So in this example, you could use either a where or a subsetting if statement. There are sometimes advantages to use use a where statement instead of a subsetting if statement. Now suppose you have a larger choice of operations that can which can be used with a where statement, okay. And if if the input data set is indexed, the where statement might be more efficient also. You may also use a where statement in a SAS procedure to subset the data being processed, okay. Now some of the very useful where operators are like suppose you can write it like is missing is null, between and, contains, like, equal to, I'll just write it down, S is missing, then we have is null, we have between and, we have contains, we have like, and we have equal to star, which is the phonetic matching. So is missing is matches a missing value, is null is equivalent to is missing, but where the subject is null. Between and is like inclusive, an inclusive range, contains matches a substring, like is matching with wildcard, where you give something like r underscore n %. So this is like matching with wildcard, and you have the phonetic matching, which is you can give as name equal to like this with suppose Nick. Okay, so these are the ways. So we'll see. Let's see. Okay, there are certain things I think before completing this I should mention that the is null and the is missing expression matches a character or a numeric missing value. The between and expression matches all the values greater than or equal to the first value and the less value or equal to the second value. This works with character as well as numeric values. Okay. The contain expression matches with any character value containing the given string. The like expression uses two wildcard operators, that is the underscore is a placeholder. Here when you use a like, the underscore, how I have shown you, is a placeholder and entered as many underscore as you need to stand for the same number of characters, and the percentage matches nothing as a string of any length. Okay, so see you in my next lesson. Till then, bye.